In the previous class, we have discussed with you about the vectors. Today, we are going to discuss that if I have two or more vectors, then can I add those vectors? So, the heading with you is addition or composition of vectors. I can say that I am going to add the vectors. So, if I am having two or more vectors, then I will be talking about the resultant vector, which is of course a single vector which is producing the same effect as the individual vectors together will produce. So it means in place of making three or four vectors, I will be talking about a single vector which will be producing the same effect as will be otherwise produced by the two or more vectors. So this process of adding two or more vectors is called the composition of vectors. Because vectors, they are having both magnitude and direction, so we have to use the vector algebra. It means we have to learn the methods for the addition of vectors. So if I'm having say two vectors with me, this is one vector. If I write here A vector, this is B vector, then the resultant is here taken in here is the R vector. Resultant vector, of course, you should be aware of, it is a single vector. Single vector which is producing the same effect as by two or more other vectors. If we are talking about the combination of vectors, this combined effect of two vectors A and B is produced by the single vector, that is R vector I have taken. And of course, R here is called the resultant of A and B, and I can write R vector, it is equals to A vector plus B vector. Here vector sign you can put yourself. I am just keeping it bold to show you these are the vector quantities. So R, A and B all are vectors. So R vector, it is equals to A vector plus B vector. Now we can add them by many ways can be there, like maybe you have heard of triangle law, parallelogram law, polygon law, vector addition is there. Even if I go with any of these methods, all the methods will give me the same result. Actually, we are doing it graphically with the help of graph, I can say. And I have to go with the analytical method basically, which is going to give you the magnitude of the resultant vector as well as the direction also. So analytical method for all these three we'll be dealing with. It means of course these are graphical methods. Actually, if I talk about the triangle law of vector addition, parallelogram law of vector addition and polygon law of vector addition, these are the different methods for addition or composition of vectors. So you should be aware of addition and composition, meaning is same. So you should not get confused with the things that you are aware of the addition but you are not aware of the composition. Meaning is same. So even if in the exam they are asking about the vector composition, the meaning is addition only. So you should be able to work out with the things. So basically we have to deal with all the three methods. We are going to start with the triangle law of vector addition first. So what it says that if supposingly I am having two vectors. So here if I am saying this as A vector and this as B vector, I can move A and B vectors parallel to itself. So whenever I am talking about these vectors, these should be non-localized vectors. It means they are free vectors. So I can move them always. Whenever I am talking about the free vectors can be moved parallel to itself. So what it is that if I am having two vectors which I can represent by the two sides of a triangle, like this is A vector, this is B vector, then the resultant will be always given by the closing side of this triangle. It means if this is A vector, this is B vector, then this is vector R. So vector R or the resultant vector is given by the third side of the triangle but in the opposite order. So this point is also to be noted. I am repeating. Here if you see A and B vectors are there which I want to add. Both are moving in the same direction. Same directions means same order. They are moving in the same order. It means order for A and B is this. It means this they are moving in the anti-clockwise direction, but resultant if you see it is going in the clockwise direction. So this point is to be noted that if two vectors are there both in magnitude and direction by the two sides of a triangle taken in the same order, both are moving in the anticlockwise order here, then the resultant is represented by both magnitude and direction by the third side of the triangle but taken in the opposite order. So this is clockwise. This is clockwise movement and this is anti-clockwise movement. So order means whether we are moving clockwise or we are moving anti-clockwise, that you people have to take care. So A and B, they are moving in the anti-clockwise direction while the resultant vector is given by the third side moving in the clockwise order. We want to have the analytical method. We want to find the magnitude and direction of this resultant vector. Same thing I have taken. This is here OA, I am calling it as P vector. AB, which is I am calling it as Q vector. It means I am now supposing that let P and Q are the vectors which are acting in the anti-clockwise order, and they can be represented by the sides or two sides of a given triangle. Then the resultant R will be given by the closing side of the triangle taken in the opposite order. So its order is clockwise. P and Q vectors, they are moving in the anti-clockwise order, but they are making an angle theta with each other. So whenever I have to find the angle theta, this angle I can take by extending the direction of A. Then the angle which is there here, it is theta. So P vector and Q vector, they are making an angle theta with each other. Now this is, we are taking phi. Phi is the symbol I am using. You may take alpha or beta, your choice it is. Any symbol you can use. This phi I am taking the angle which the resultant vector is making with the first vector, that is P vector. In place of P and Q, you may call it A and B, and then naming you can do in a different way. Even you can change the directions. Even theta can also be changed if I make this B vector like this, then the value of theta will be different than this value. So then your phi will also get changed. So you have to see whatever way you want to draw the diagram, that is totally your choice. So I am taking P vector and Q vector. Theta is angle between P and Q. Phi is the angle which the resultant vector is making with the first vector, that is P vector. Here, of course, you can put the arrow mark over all these because that is your, these all are vector quantities. So I am not putting it. You can put the vector signs over P, Q and R. I have written simply in bold to specify the things, that R vector, it is the resultant vector, is given by the sum of P and Q vectors. Now what we have done, we have drawn a perpendicular from B to this P vector produced. It is meeting here at C point and this angle is 90 degree. So this is your right angle triangle. It is becoming OCB is a right angle triangle. In this right angle triangle, if you see this OB square, it is equals to OC square plus BC square. Because this is a right angle triangle, by Pythagoras theorem, you know that your OB square hypotenuse, it is equals to base square plus perpendicular square. So now if you see the diagram, here OB is written by, of course, it is giving me the magnitude of R vector. OA is giving me, if I simply measure the length, then it is giving me the magnitude of P vector. And AB, it is giving me the magnitude of Q vector. So now if I leave the direction, I am simply focusing on the magnitudes, analytical method. Now if you see in this diagram, this side OC can be written as OA plus AC. So in this equation, in place of OC, I can write OA plus AC. And if you see this small triangle now, ABC triangle, here you can see cos theta, if I want to write by your knowledge of trigonometry, you can write the value of cos theta, that is equals to base upon hypotenuse. It means AC divided by AB. Here you can see AC divided by AB, but or you can write AC, it is equals to AB cos theta, because I know the value of AB is Q. Here I mean the magnitude of Q. If you want to be more specified, you can put the modulus sign and you can put an arrow. It means I am talking about the magnitude of Q vector. Here similarly, if you want to write sine theta, that is perpendicular upon hypotenuse, it means BC upon AB. So you can find the value of BC, which is given by AB sine theta, but AB it is equals to magnitude of Q vector. So you can put the modular sign and arrow over it. So it is Q sine theta. So now I am getting the values of AC and BC. I can put it in this equation number 1. And if I put the value, I am getting here OA, of course it is P. AC I have seen it is coming out to be Q cos theta whole square plus BC whole square means Q sin theta whole square. Now if you work it out, I am getting P square plus 2PQ cos theta plus Q square cos square theta plus Q square sin square theta. Now this cos square theta plus sin square theta, it is equals to 1. So I am left with only Q square here. So if you are willing to write the magnitude of R vector, of course you can put the modulus sign and arrow over it to be more specified. Here I am not writing anything, it means I am talking about the magnitude of R vector. I am not doing it bold as well. So this is given by square root of P square plus 2PQ cos theta plus Q square. This is giving me the magnitude for the resultant vector. I want to find this value phi. So for that, again I will be taking this bigger triangle, right angle triangle of this OBC. Then if you write the value of tan phi in this triangle, then tan phi is your perpendicular upon base. It means BC divided by OC. But OC is what? OC is OA plus AC. We have already find it out. The value of OA we know it is P. For AC also we know it is Q cos theta, and for this BC also we have calculated, that is Q sin theta. So if I put these values, I can get the value of tan phi, which is BC upon OC, and you put the value of BC and OC, and then you can write phi, it is equals to tan inverse Q sin theta divided by P plus Q cos theta. So this is the equation for the direction of the resultant vector. So you should be able to write the direction of the resultant vector, and it is very important whenever it is coming for any vectors. So even if in the question they don't mention that you have to find the direction in some numerical, I mean, then in that case it is obvious that you have to give the direction and magnitude both, because whenever you are calculating any vector quantity, magnitude and direction both are expected from you people. So you see to it, and this knowledge of vectors is very important for the covering your 11th and 12th both the classes, because many times we are coming across many vector quantities in physics. So whenever vector quantities are coming in physics, always you have to take care of the magnitude as well as direction. So that is why I am giving you this much time to make you the things understand, because if the thing is not clear, then you will get struck always. So this is a very important topic with you, and I am taking in a whole detail with you people. Now they may ask that this theta here I have taken less than 90 means acute. You draw the triangle when theta is obtuse. It means you will be drawing the Q vector this way, and then resultant as I drawn on the first sheet. Then resultant will be given this way. Then how will you complete the diagram and calculate the magnitude and direction of the resultant vector? You take that as in question with you. Try it yourself. This is for the magnitude and direction of the resultant vector using triangle law of vector addition. Next with you is parallelogram law of vector addition. Now what it is, here I have the two vectors P vector and Q vector, but they can be represented by the two sides, adjacent sides of a parallelogram. In that case, according to parallelogram law vector, the resultant will be given by the diagonal of this parallelogram, but starting from the same point where these points are starting. So you cannot take the other diagonal. It means you have to take the same diagonal which is starting from the same point. So if you go with the statement, you can see if two vectors can be represented by two adjacent sides of a parallelogram in magnitude and direction, then their sum is given by the diagonal of the parallelogram through their common point in magnitude and direction. Because in the previous diagram also I have taken P and Q as the vectors, same naming I am keeping so that you are able to understand the things in a better way. Again, I want to find the magnitude and direction for this resultant vector. So this angle is between the P vector and Q vector. This is theta. These are two vectors P and Q. If you complete the parallelogram, this means AB side will be equals to your OD side. So AB is again Q vector. This direction is parallel because these, of course, we are talking about the free vectors. So now this angle is theta, it means this angle is also theta. And this small angle which the resultant is making with the P vector, that I am taking supposing same as phi. So this angle is phi. So my suppositions I am keeping same so that in analytical method you are comfortable with the things. Then for both you can write the same steps. Now if you want to derive the expression for the resultant vector, again my suppositions are same. P vector is represented by OA. I can draw the perpendicular from B to OA produced. It is meeting at C. This angle is 90 degree. This angle is theta. Again, it means you can write R square. It is equals to, by taking this bigger triangle OBC, you can write OB square, it is equals to OC square plus BC square, and same thing where you can write the value of OC which is equals to OA plus AC. So I want to find the value of AC, I want to find the value of BC, so I will be taking this small triangle OBC. I will be finding cos theta. Cos theta is base, it means AC base divided by hypotenuse, it means AC divided by AB. So you can write the value of AC which is equals to AB cos theta, or you can write Q magnitude. This here you can put the modular sign and vector sign. I am talking about the magnitude of Q vector which is coming out to be Q cos theta. Similarly, you can write the value of sin theta which is BC upon AB. So you can write BC, it is equals to AB sin theta, or you can write Q magnitude into sin theta. Now if you put the values of AC and BC in this first equation, then again you are getting the value of R square. By putting the values on solving, you are getting the same result as we got in triangle law vectors. It means we are getting the magnitude of R vector is square root of P square plus 2PQ cos theta plus Q square. So all the steps are same as mathematics is concerned, but the diagram you have to see, we are talking about the parallelogram law of vector addition. So it means parallelogram law of vector addition is nothing but simply the extended form. It means here if you see OAB, this triangle, this is following the triangle law vector. But here I am talking about this Q vector, so it means I am taking simply making parallelogram. You all know all the sides are parallel. Your opposite sides, they are parallel, as well as magnitudes are also same. So magnitude of OD, it is equals to magnitude of AB, and direction is also same because both are parallel. So this is a diagram you have to focus, and you should be able to find the magnitude for the resultant vector. So same way you can find the direction also, tan phi, which is given by BC upon OC, and if you put the value of BC and OC, you are getting tan phi, it is equals to Q sin theta divided by P plus Q cos theta. So this you should be knowing, and you can write the value of, you can in the numerical you can find simply tan phi, it's okay, or you can write the result in terms of phi equals to tan inverse Q sin theta divided by P plus Q cos theta. So this way you can always find the direction also for the resultant vector. I want to talk about some special cases when parallelogram law of vector addition is being used. These are the formulas I have simply written again with you. Formulas we have derived for the magnitude of R vector. This always you are preferred to write with the modulus sign and an arrow over it, that is showing the magnitude. That is equals to square root of p square plus 2pq cos theta plus q square. These both the formulas are known to you for magnitude and direction. Now my first case is that if theta is 0, it means p and q both are acting along the same line. They may write it this way also. P and q, they are acting along the same line. Then in that case theta is 0. Then you can find the value of magnitude of R. And if they are perpendicular, it means if this is p vector, this I am saying q vector. Second case, of course, p vector and q vector are perpendicular. And the third case is p vector and q vector, they are moving in the opposite direction. Three cases we have to take. So let us take one by one only. First case is if theta is 0, p and q both are acting along the same line. If theta is 0, same direction, then what it is, it means you put the value of theta 0 in this equation for the magnitude of R vector, which is cos 0 is 1. So when cos 0 is 1, it means you are getting square root of p square plus 2pq into q square. It means you can write it as p plus q whole square. Whole square and square root, they will cancel, and I am coming with the result R equals to p plus q. This is the case 1 when theta is 0. Now if you want to find the direction here phi, then sine 0, it means the direction of resultant vector will be same as that of p and q vector. Second case is if theta is 90 degree. Theta is 90, it means p vector and q vector, they are perpendicular to each other. P is this way, q is this way. So by using triangle law, resultant you can find by drawing the diagonal. And if you want to find the magnitude of this resultant vector, then again in this equation you put theta equals to 90 degree. Theta 90 means cos 90 means 0. So you are left with R equals to, of course, magnitude of R, it means modulus sign and arrow vector you can put. That is coming out to be square root of p square plus q square. In this case, if you want to find phi, that is coming out to be tan inverse q upon p. So it will depend upon the magnitude of q and p where the resultant will go. It will come closer to p vector or it will come closer to q vector. That will depend upon the magnitudes of q and. Third case, if theta is 180 degree. It means both the vectors, they are moving in the opposite direction. P is moving in this way and Q is moving in the opposite way. Then, of course, here cos 180, it means P square minus 2PQ plus Q square. So, you can write P minus Q whole square. Square root of course, square root and square sign will go. So, I am left with R equals to P minus Q. And direction of the resultant, of course, will be in the direction of the greater vector. So if Q is greater, then direction will be towards left. If P is greater, then direction will be towards right. This here resultant will always act in the same direction of P and Q. Both are acting in the same direction. But when both are acting in the opposite direction, then the direction will be same as that of the greater vector. So these are the three cases which you have to deal when we are talking about the parallelogram law of vector addition. So parallelogram law of vector addition, it means it is covering the triangle law of vector addition. So parallelogram law of vector addition is more important for you. So you have to keep always in mind. Next with you is the third law, which is the Polygon law of vector addition. Now if I am having more than two vectors like A, B, C, D, 4 vectors are there, and I want to add, then up to this point you have understood always we are talking about the free vectors. So whenever I want to move the free vectors, I will be moving it parallel to itself and magnitude has to keep the same, means length is to keep the same. So when I represent it by moving it parallel to itself, So you can see they all have been moved parallel to themselves, and we can represent an open polygon by the help of all these four vectors. Then resultant will be given by the closing side of the polygon taken in the opposite order. So this is the extended form of triangle law of this. So here A, B, C, D, they are acting in the anti-clockwise direction, and this resultant vector is acting in the clockwise direction. So if you want to state polygon law of vector addition, it states that if a number of vectors can be represented in magnitude and direction by the sides of a polygon taken in the same order, then the resultant in magnitude and direction is given by the closing side of a polygon taken in the opposite order. For this, whenever it comes in question, for every step you have to find the magnitude. It means I cannot add more than two vectors to find the magnitude. So I will be finding the magnitude of A and B by completing this triangle OLK. Then this resultant OL is giving me the value of A plus B. Now if this vector OL and if I am taking LM, which is C vector, they are again acting in the same order. So by triangle law, the resultant of these two vectors will be given by OM. So OM is coming out to be A plus B plus C vector. Now if you see this triangle OMN, then again you have to apply the triangle law. So OM plus MN, they both are in the same order. So this will be given by the resultant R in the opposite order. So as a result, R vector, I am getting OM plus MN, but OM is A plus B plus C vectors. So this can be written as R vector can be written as A vector plus B vector plus C vector plus D vector. So all the vectors will get added at the end. So for such numericals, you have to go step by step, find the magnitude for the first resultant, then second resultant, and then the final resultant. So you can use the triangle law for the different steps, and then you can find the result. So this is polygon law of vectors if I want to add more than two vectors. So firstly, of course, you should be aware of the triangle law, and then you should be able to apply the polygon law. For this, you have to do in 3 steps. It means to find the resultant of magnitude and direction. So these type of questions on the basis of polygon law, triangle law, all can be asked in the numericals we will be covering in the next lecture. Thank you.